for number 1, we have 4 test scores, 74, 77, 84, and 81. They want to know what the score would be needed for a 5th test to obtain a mean of 80 for all 5 tests. So this word right here, mean of 80, should be making you think about your procedure for finding this answer. So we're going to be finding the mean, which means we're going to be adding the test scores, dividing by the number of test scores, and setting that equal to 80. So we have our first test score, the second test score, the third test score, the fourth test score, and then we don't know what the 5th test score is, so we're going to put that as x. And then since we're talking about mean, we need to divide by the number of values. There are 5 values for the test, and a mean of 80 means we want that mean to be 80. Okay, so the way I'm going to do this to solve for x is I'm going to first add these values on the top. So when I add 74, 77, 84, and 81 on my calculator, I get 316, and then I'm going to copy down the rest of my fraction here and the rest of the problem. Okay, so now I have this 5 on the bottom of my fraction that I need to get rid of, and it's division. We're dividing by 5, so we're going to do the inverse of division. We're going to multiply both sides of the equation by 5. That way over here it'll cancel out, and we're left with 316 plus x is equal to 80 times 5, which is 400. And then our final step for solving would be subtracting 316 to both sides. So we get x equals 400 minus 316, which is 84. So my answer is 84. That would be the score needed on the 5th test to obtain the average of 80. Okay, number 2. The diameters of bolts produced by a certain machine are normally distributed with a mean of 1.20 inches. So they're giving us a mean so far, and a standard deviation of 0.01. What proportion, okay, of bolts will have a diameter greater than 1.211 inches? So this is very important. They want to know greater than. Okay, so what we need to look at is that they're giving us the mean, the standard deviation, they're giving us a value, okay, and they want to find the proportion greater than. So we're going to go ahead and draw just a quick picture of what they're asking. Okay, so since it's normally distributed, I can use my bell-shaped curve, and the mean would go in the middle. Standard deviation is 0.01, so that's going to tell me here that would be 0.22 and so on if you were to want to lay all this out. So that's kind of a quick picture of this. And then they want to know 1.211, which would be about right here for my value, and what's greater than that. So if we drew this visual, they would want to know the area that's shaded over here to the right, or greater than. So we're going to go ahead and use our z-score formula, because we are going to need to use our table. Let me remind you guys, we're going to be using this to find that area of the shaded, or greater than. So z is equal to the value minus the mean divided by standard deviation. So the value that we are looking at is 1.211. The mean, very clearly stated, is 1.20, and the standard deviation, clearly stated, is 0.01. So we're going to use our calculator to subtract and then divide by 0.01, and we get a z-score of 1.1. Let me just double check that real quick. Okay, 1.1. So now what we're going to do is we're going to look that z-score up in our table and find the area from the table. So I look at 1.1. So I go 1.1 over to 0, and I get 0.8643. So 0.8643 would be the area from the table. Okay, but the table tells us the area less than. So the table just told us everything less than the value, everything over here. So we have to do the complement to find greater than. Every time it asks for greater than, you take that table value and you subtract it from 1. So it's 1 minus 0.8643, and we get our answer of 0.1357. So our answer would be B for the proportion. Okay, moving on to number 3. A football team has a mean height of 67 inches, so there's our mean. Our standard deviation is 5 inches, and we want to know which of the following is true about a team member who is 73 inches tall. Okay, so whenever they're giving us the 3 values, we need to be thinking about the z-score formula, and we need to be thinking about maybe drawing a visual to help us. So we know the mean always goes in the middle, 67, and then that standard deviation of 5 is telling us the spread. So 1 standard deviation above would be 67 plus 5, so I get 72, plus another 5 is 77, and plus another 5 is 82. And then if we go below, we would subtract 5 from the mean for 1 standard deviation below. 2 standard deviations below, we would subtract 5 again and subtract 5 again. Okay, and we're talking about a team member who's 73 inches tall. So if these are all of those heights, 73 would fall about right here. So that would be above the mean about 1.2 standard deviations. So this would be 1 standard deviation, if this is 0 at the mean, 1 standard deviation, 2 and 3, 1 standard deviation below. Okay, and this is about 1.2 standard deviations above the mean. Okay, so another way we can do that is using the z-score. So if I use my formula for the z-score, it's my value minus the mean divided by standard deviation. So we plug in the guy's value, or girl, whoever it is, team member, 73, and subtract the mean and divide by standard deviation. It will give us a z-score of positive 1.2. So again, that puts us right here at 1.2 standard deviations above the mean, because the z-score is going to be the number of standard deviations away from the mean. So positive means we're above. Okay, so we are going to find the area of the shaded region for number 4. We are given that there's a mean of 900 and a standard deviation of 153, and we're looking at our own value of 747. So again, they're giving us the 3 values. We're looking for the area shaded to the right or greater than. So let's keep that in mind. We're going to first use our z-score formula. We have our value minus the mean divided by the standard deviation. Okay, and when I do that, I end up with -1. All right, so if I look that up in my table, if I look up -1, I get 0.1587. Okay, so that is not going to be the area that's shaded. That's telling us the area to the right, because the table values tell us the area to the right. So again, because this is greater than, we have to do the complement, which means we are going to subtract the table value from 1. Sorry about that, you guys. It's a little early to be making mistakes in this video, sorry. Okay, 0.1587. And then in your calculator, you get 0.8413. and that is going to be my answer, okay? But they do, yeah, that's going to be my answer. So it's 0.8413 or about 84%. Okay, so we'll just leave it as that. All right, so we're going to find the percentage, this time they want percent, of the distribution that falls within the shaded region. The graph depicts the normal distribution with a mean of 0 and the standard deviation of 1. Okay, so for this one, we have values that lie exactly -3 below and then 2 above our mean. So this time, we are going to be using our 68, 95, 99%, 99.7% empirical rules. So I'm going to remind you guys of those rules. We know that when you're within 1 standard deviation above and below, it accounts for 68% of the data. If you are within 2 standard deviations from the mean, it accounts for 95% of the data, and within 3 standard deviations, it accounts for 99.7%. So what we have here is shading overlapping on both sides. So the way we're going to do this is we're going to break down each side and then we're going to add it. So I'm going to first look at the left side of the mean. So from 0 to -3. I'm going to find that percentage and I'm going to add it to the right side of the mean between 0 and 2. So to find this percentage, I need to see that on the left, I'm 3 standard deviations below. So I will be using 99.7, that's my rule for 3 standard deviations. But since I'm on one side of the mean, I'll be dividing that by 2, and I get 49.85%. Okay, so that is going to be on this left side of the mean. So then on the right side of the mean, to find the area over here, I'm now 2 standard deviations above, so I'm using my 95% rule. But since I'm only on one side, I need to divide that by 2. So I get 47.5 is going to be my percentage over here on the right. So I'm going to take both of these percentages and I'm going to add them. All right, and then that is going to give me my answer of 97.35%. Okay, and that's the percentage that is shaded. Okay, number 6, we are going to talk about looking at these sets of dot plots and figuring out which set has the largest standard deviation and which set has the smallest. So when we are looking at dot plots, we need to remember that when we're looking for the mean, okay, we kind of look at the middle. So in part A, right here at number 3, that would be our mean, okay? So when we talk about standard deviation means the distance from the mean, okay? So our distance from the mean. So if we look here, the distance from the mean, all of these points are 1 away from the mean. So we've got quite a few points that are 1 away from the mean, okay? Then we have lots of points. We've got 10 different points that are 2 away from the mean. So we've got a lot of points that are pretty far away from the mean, meaning this has a pretty high standard deviation, okay? So lots of points away from the mean means a very high standard deviation compared to these points where we have less away from the mean here. So we're going to have A as our largest standard deviation. Okay, so now we're going to look at the smallest. So if we look at number 3, we have 7 points that are 1 standard deviation away from the mean. We have 7 points that are 2 standard deviations away from the mean. So average distance from the mean, okay, for standard deviation. And that's happening, okay? So again, our mean would be for C here. We have 8 points that are 1 standard deviation away, and then we have 4 points over here that are 2 standard deviations away. Okay, so what we have is that right here, this number, 2 standard deviations away, or 7 that are 2 standard deviations away is still a pretty big number, okay? Not as much as what we had over here where there were 10 that were 2 standard deviations away, so this is still a pretty big spread that we have here. And then if you look at, we only have 4 points out here that are 2 standard deviations away. So just comparing those is telling you that C has the smallest standard deviation. Okay, so our answers would be A and C. All right, number 7. We are going to look at this histogram for exam scores. Which measure of center would be more appropriate to represent the data? All right, so we do want to remember that we use the mean anytime the data is symmetric or normally distributed. We use the median anytime we have skewed data or outliers. So in this case, we do have an outlier, so we do want to use the median. So our answer is C, the median, because there's an outlier. Okay, number 8. We're going to find the area of the shaded region again for this graph that depicts the normal distribution with a mean of 1,160 and a standard deviation of 11. So again, they're giving us our value right here. So we're going to go ahead and use our z-score formula so we can look up our numbers in our table. So z is equal to, I'm going to write it for you guys again, value minus mean divided by standard deviation. So we have our value of 1,154.72 minus the mean, which is 1,160, divided by our standard deviation of 11. So when I put that into my calculator, I'm going to get a z-score of negative 0.48. Okay, so now what I need to do is go ahead and look that up in my table, and the table is going to tell me my area to the left. So my answer will be this area when I look up negative 0.48. And that is going to be from my table. I'll go ahead and show you guys again how to look that up. Negative 0.4 meets the 8. Zoom out a little bit. So here's the 8 meeting our negative 0.04 at 0.3156 right there. Okay, so 0.3156 comes from my table. So actually for number 8, that problem got a little messed up, so that's not one of our multiple choice answers, but this is the area shaded to the left of my value. Okay, so we're going to move on to number 9. Similar problem, giving us the mean, they're giving us the standard deviation, and they're giving us a value that we want to find, but this time we're shaded to the right or greater than. So it's going to be an extra step. We're going to be finding the complement of the table value. So again, we are going to use the z-score formula. We have a value of 404.24 minus the mean of 410 divided by standard deviation of 24. When we do that in the calculator, find my notes here, we get negative 0.24. All right, so negative 0.24, we are going to look that up in the table to find the area. So looking up negative 0.24 gives us an area of 0.4052 from our table. So we need to remember the table value does not tell us what's shaded to the right. It tells us what is shaded to the left. So we have to do one extra step because they want to know greater than. So we will be subtracting from 1. Okay, so we get our answer of 0.5948, which again is not one of our multiple choice answers. Okay, so that's going to be our area greater than the value. Okay, number 10. We are going to be solving for W, so this takes us back to previous units where we worked on exponential equations. So when you have the base of 16 and 64, we have to try to think of how can we rewrite these numbers to have the same base. So we're going to rewrite these as exponents with the same base. So a good exponent to choose, or a good base to choose, would be 4. So we're going to rewrite 16 as 4 squared, but we need to just write down that old exponent. We're going to keep the 2w. And then we're rewriting 64 as 4 cubed, because 4 times 4 times 4 is 64, and we are going to just rewrite that old exponent. Okay, so now that we have the same base, we can get rid of them using logs. Log base 4 to both sides is actually going to completely cancel out my base 4s, and I'm going to be left with 2 times 2w is equal to 3 times w plus 2. So if I go ahead and solve this equation for w, I'm going to get my answer. So 2 times 2w is 4w, and then distributing here gives me 3w plus 6, and then moving over 3w, I get my answer of w is equal to 6. Okay, number 11. This time I have a log equation that I'm going to solve. So remember, to get rid of log base 5, we need the exponent with a base of 5. So we're going to go ahead and do that to both sides. And that is going to cancel this log base 5 out for us to leave us with x is equal to 5 to the power of 1/2. So 5 to the 1/2 power we can rewrite as the square root of 5. So our answer is C. Okay, number 12. The heights of 300 randomly selected men are measured and recorded. The sample standard deviation is 1.6 centimeters. We want to know the variance. Okay, so some of you have memorized that variance is just the standard deviation squared. Okay, it's just the standard deviation squared. So they're giving us the standard deviation is 1.6. So if I want to find the variance, I just square 1.6. And 1.6 times 1.6 gives us our answer of 2.56 centimeters, okay? So that's one way to look at it. I'm going to show you another way based on how we find standard deviation. You guys learned about MSAR, MDSAR, okay, to help you find the standard deviation. So when you're on your answer over here in step 5, your answer is the standard deviation. Remember, step A, your answer is the variance. So when we work through this to find standard deviation, to get from the variance to standard deviation, you guys look at R, which means you find the square root. So moving here, you do the square root of your variance, or your answer in step 4. So in this case, where they give us the standard deviation is 2.56, and they want us to go backwards to variance, we now are going to do the inverse of square root. We're going to square the value. So 2.56, or I'm sorry, not 2.56, 1.6. Sorry guys, I'm making mistakes. They told us the standard deviation was 1.6. So to go backwards to the variance, we just square 1.6. Okay, so you get 2.56. But I think for us just memorizing this, that variance is standard deviation squared, is going to help us be successful with that question. Okay, number 13, the diameters of bolts produced by a machine are normally distributed with a mean of 1.6 and a standard deviation of 0.01. They want to know what proportion of bolts will have a diameter greater than 1.589. So that's important. They want to know the greater than. All right, so here we go again. We're going to find that z-score so we can look up our proportions, our areas from our table. So z is equal to my value. They want to know what's greater than 1.589, so that's our value, minus the mean divided by the standard deviation. So when you do that in your calculator, you are going to get a z-score of negative 1.1. So we're going to go ahead and look that up in our table so that we can find the area less than. So looking that up in the table, negative 1.1 gives us the area of 0.1357. Okay, but we need to remember this is the less than from the table. So if they want to know greater than, we have to subtract that table value from 1. Okay, so we end up with an area or proportion of 0.8643. So our answer is B. Okay, number 14. A tire company produces a tire that has an average, so let's keep in mind that's another word for mean, lifespan of 40,000 miles with a standard deviation of 5,000 miles. The distribution of lifespans of the tire is normal. What percent, that's important, of the tires last at least 42,400 miles? So really quick, you guys, at least is kind of tricky because we think it means less than because of the word least, but it actually means greater than. So I always use the example for that when I talk about desks in my classroom. If I have 40 students, I need at least 40 desks in my class. So that means I cannot have less than. It actually means I need greater than or equal to 40. So remember, at least means greater than or equal to. Okay, so again, we are going to use our formula to find the z-score so that we can find the area in our table. So z equals to the value we're talking about, 42,400 tires, minus the mean divided by the standard deviation. And that's going to get us a z-score when we put this into our calculator of 0.48. Okay, so again, we need to find the area. When we find the area on our table, when we look up 0.48, we get 0.6844. So remember, that value is for less than. We're looking for greater than in this problem, so we are going to subtract that value from 1. So we get an answer of 0.3156. All right, so they're asking us for percent. So remember, to find percent, you just take this area or this proportion and move your decimal twice. So my answer would be 31.56%. So my answer is A. Moving on to number 15. We have the same type of problem again. A tire company produces a tire that has the average lifespan. So remember that that's another word for mean. Average is another word for mean. With a standard deviation of 4,000 and the distribution of lifespan is normal. What percent of the tires are at most, last at most 35,400? So at most, kind of like at least, it does not mean more than. It means at most. It's limited to 35,000. So it actually means less than or equal to. Okay, so super important that we understand that. All right, we are going to look up areas in our table again. So we're going to need z-scores. we're going to have our value this time, 35,400, minus our mean of 40,000 divided by the standard deviation, which is 4,000, and that gives us a z-score of, put that in the calculator, negative 1.15. All right, so we are going to go ahead and look that up in our table. Negative 1.15 will give us an area from our table of 0.1251. Okay, and since they're asking us for the percent less than or equal to or at most, this is going to be our answer. We don't do the complement, just simply our answer from the table tells us less than. They do want to know the percent, so we need to move the decimal twice to the right, and we get an answer of 12.51%. So my answer is C. Okay, now we have a problem asking us about population standard deviation. All right, so they're just helping us out and telling us the mean is 4. So they're helping us with our first step. So remember our procedure. We're going to be using this here, and they help us find the mean is 4. So they did step 1 for us. Okay, so remember step 2 is to find the difference. I'm going to go ahead and erase that for a second. D stands for difference, so you're going to take each of the values and subtract or find the difference from the mean. Each of the values we subtract the mean. So we get negative 3, 4, 0, and negative 1. All right, now we're moving on to step S. S stands for square, so we're going to take each of our values from step 2 and square them. So negative 3 squared will give us 9, 4 squared is 16, 0 squared is 0, negative 1 squared is 1. Step 4, we're going to find the average. Since it's population standard deviation, we just take our normal average, which means we're taking the values from step 4, we're going to add them, and then we're going to divide by the number of values, so we're going to divide by 4. So we get, when I add all of this in my calculator and divide by 4, so it's going to be 26 divided by 4, I get an answer of 6.5. Okay, so we have a variance of 6.5. I'm going to go ahead and take that to step R. R stands for root, square root, so we take our answer from step 4 and do the square root in our calculators, and we get an answer of 2.55 when we round. So that is our answer for number 16. Okay, number 17. Longevity of people living in a certain locality have a standard deviation of 12 years. What is the mean longevity if 20% of the people live longer than 75 years? Okay, so they're giving us a lot of information. They're asking us to find the mean. Okay, so we are going to draw a picture. When we're given a type of problem like this, I think it's most helpful when we draw. So we are given that we want to find the mean if 20% of the people live longer than 75 years. So we need to break that apart, okay? So I would say if this whole thing accounts for 100%, right, the whole thing is 100%, 20% would be over here, 20%, because they want to know who lives longer. So living longer would be towards the right because it's more years when you're on the right. So 20% would be here, and that is what they want, or what they're giving us. So what we know is from this value to the left is going to then be 80%. So when I am going to use my formula and look this up, I need to understand that I'm going to be using the z-score formula. So I'll be using this one, value minus mean divided by standard deviation. But with this information right here, okay, I'm using the one to the left because the table is going to talk about shading to the left or less than whatever my value is. So the first thing I need to do is look up the area in my table. So I'm going to look up the area of 0.80 so that I can find the z-score. So what I do is I grab my table and I look for the area of 0.80. So this is the negative z-score side. So I'm not over here. These are smaller areas. So 0.80, I'm going over here and it falls right about here. Okay, so what I'm going to do, I'm going to pick this one and I'm going to look for the z-score. So the z-score then is going to be 0.84. Okay, so that is what I need to look for, 0.84 as my z-score. I just found that from looking at my table. Okay, so now we have a z-score. We have a standard deviation. And we have a value. So we're going to plug these into our equation and we're going to find m. So I have the z-score of 0.84 is equal to my value, which is 75, minus mean, which I don't know, so I can go ahead and leave it as mu or an x, however you want to do it. And then I have standard deviation is 12. So what I'm going to do is I'm going to solve this and find that mean. So to do that, I'm going to get rid of my fraction by multiplying both sides by 12. So 12 times 0.84 will give me 10.8. 0.08 is equal to 75 minus my mean. And then to solve this, I'm going to subtract the mean, or I'm sorry, subtract 75 to both sides. So if we do that in our calculator, we're going to get negative 10. Just want to double check. Negative 64.92. And the last step would be to divide both sides by a negative 1. So my answer is 64.92 for my mean. So that would be that average age. So right here, 64.9 would be our answer. Okay, number 18, review of trig. So they're telling us that we are going to find the angle given a negative sign and a negative cosine. So in our unit circle, we have a negative sign and a negative cosine when we're in quadrant 3. Negative sign and negative cosine. So I'm going to go ahead and label my triangle with a sine opposite over hypotenuse of negative square root 3 over 2, and cosine is going to be our adjacent over hypotenuse. And I'm going to find this angle. So where am I on the unit circle? So since this is square root 3, I know this is a 60-degree reference angle. So this is 180 degrees. If I add that reference angle, 180 plus 60, that takes me to 240 degrees on my unit circle. So my answer is C. Okay, solving an equation. This is a review from a while back. So when we are given this type of problem, we want to get rid of our denominators. So I'm going to multiply all three of my terms by P and p minus 3. So over here, I'm going to multiply p and p minus 3, p and p minus 3, and p minus 3 to all of my terms. So over here on my first term, when I do that, the p minus 3's are going to cancel, and it'll leave me with p times p, so p squared. Then over here, when I'm on my second term, the p is going to cancel, and it leaves me with plus 6 times p minus 3, and that will be equal to 1 times p minus 3, so nothing's going to cancel out there because there's no denominator on that right side. So I'm going to get rid of my parentheses. Oops, minus 3p. And I want to solve this equation. So what I'm going to do is I'm going to combine my like terms. I'm going to use inverse operations. So if I try to move this p squared over here to this side, that's going to cancel them out on both sides. Okay, so I'm going to go ahead and move over the 3p over here, and I get 9p minus 18 equals 0. So this is actually going to give me a two-step equation that I just need to get p by itself. So if I just move over the 18, I have 9p is equal to 18, and then the final step to get p by itself is to divide by 2, or to divide by 9. 18 divided by 9 is 2. Number 20. If you were to add 4 to each of your numbers in a data set, which of the following would result? Okay, so remember when you're adding a number to all of your data, it's called shifting. Shifting. All right, so when we are shifting, we want to remember that every single time your measures of center are also going to shift. So measures of center, like mean, median, and mode, are also going to add 4 or shift 4. And then your measure of spread, like standard deviation, variance, those things are going to remain unchanged. Okay, so when we're adding 4, the standard deviation is not multiplied by 4. No, wait. Standard deviation does not change when you're shifting or adding 4. The standard deviation increases by 4. Nope. The mean is multiplied by 4. No. The mean would also increase by 4. So your answers are B and F. Number 21, which of the following is a factor? So this takes us back to factoring. We're going to use our procedure, our shortcut, that we look at our first term, what two things multiply to give us 3b squared. It'll be 3b and b. And two numbers that multiply to give us 10. We will try 5 and 2. And it needs to add up to a negative b. Remember the middle term. So when I multiply diagonally, I get 5b and 6b. So we look at these. What number needs to be positive? What needs to be negative to give us negative b? It'll be a positive 5 and a negative 6. So you carry over the positive and the negative, and we get 3b plus 5 and b minus 2 as our factors. So I see the 3b plus 5, the b minus 2 isn't there, so my only answer here would be C. Okay, now we're talking about multiplying each number in a data set by 4. So we're multiplying everything by 4, and that is what we call scaling. We're going to scale. So what's going to happen when you scale? So overall, I'm going to remind you guys that when you scale or multiply a number, your measures of center will also be multiplied by that number. So in this case, they'll be multiplied by 4. And your measures of spread will also be multiplied by 4. So the standard deviation is multiplied by 4, yes. The standard deviation would not change, no. Standard deviation increases by 4. No, that's adding 4. That's for shifting. The mean would be multiplied by 4. Yes. Mean does not change. Mean increasing. No. So our mean and standard deviation are also multiplied by 4 if you do that to all of your data. Okay, moving on to trig, sine of 30 degrees. 30 degrees falls in our first quadrant. So when you're in your first quadrant, that's going to be also your reference angle. And a lot of you in the other Algebra 2 classes just have that memorized. Sine of 30 degrees is 1/2. But for my class, we know opposite of 30 degrees is always 1. And in the 30, 60, 90 triangle, we have a hypotenuse of 2. So sine is opposite over hypotenuse, 1/2. Number 24, sine of 5 pi over 6. So it's much easier if we go ahead and turn that radian into degrees. So we can do that by multiplying by 180 degrees over pi. So we can convert to degrees. So those pi's will cancel. If we cross cancel, this becomes a 1, this becomes 30 degrees. 5 times 30 degrees is 150 degrees. So we're trying to find sine or evaluate sine of 150 degrees. So I'm going to go ahead and first put 150 degrees on my unit circle. Oh, my bad, guys. 150 is not there. 150 degrees. And this is 180 degrees. So I'm going to draw my triangle. And I'm going to write in my reference angle, which is 180 minus 150, 30 degrees. So I'm finding sine, which means I want the y, or opposite of 30 is 1, by hypotenuse of 2. So my answer is opposite over hypotenuse, or 1/2. Okay, and it is positive 1/2 because I'm in the second quadrant and I have a y value that's positive, or sine value that goes up. Okay. 25, evaluate sine of 5 pi over 4. So similar to what we did in the other problem, we're going to go ahead and put this 5 pi over 4 into degrees by converting, multiplying 180 degrees by divided by 4, and that means our pi's will cancel, and if we cross cancel, 180 divided by 4 gives us 45 degrees. 5 times 45 is 225 degrees. So we're finding sine of 225 degrees. So again, I'll try to draw this a little bit better. I'm going to plot 225 degrees. This is 180, this is 270, so it's falling right here in the middle. Draw my right triangle, and my reference angle then is 225 minus 180. It gives us a 45 degree reference angle. So we are looking for sine. We're looking for this y, or the opposite over hypotenuse. So for opposite of 45 is going to always be 1 with a hypotenuse of square root 2. But since I'm in the third quadrant, I know my sine is negative. This y value goes down negative, so that's why I know it's going to be a -1. So sine is opposite over hypotenuse, so opposite over hypotenuse, but we do want to rationalize by multiplying square root 2 to the top and bottom. So I get negative square root 2 over 2 for my answer. Number 26, we have another log equation that we're going to solve. So to get rid of log base 7, we want our exponent with a base of 7 to both sides. So that right here is going to cancel out and leave us with x is equal to 7 to the 1/3 power. 7 to the 1/3 power actually means the cube root of 7. So that's why we get D. Which of the following expressions are equivalent to -1? So I'm going to go ahead and work out each one of these separately. I will start with A, maybe down here. I'm going to find tangent of 3 pi over 4. So I'm going to go ahead and convert 3 pi over 4 into degrees, and I get 135 degrees, so I'm finding tangent of 135 degrees. So I'm again going to plot 135 degrees here in the second quadrant. 135, this is 180, which is going to give me that 45-degree reference angle, the 45, 45, 90 triangle. Tangent, I know, means opposite over adjacent. So opposite of the 45 degree is 1. This is also 45 degrees, and opposite of 45 is always 1. On my x-axis over here, this is a negative 1 because it's going to the left. So opposite over adjacent would give us this from my reference angle, remember? So opposite over adjacent, which gives us an answer of negative 1. So that's going to be our first answer. So we want to make sure we are looking for more than 1. R is plural, not singular, so we're looking for more than 1 answer. All right, let's go to B. Give myself enough room here. I'll do B up here. B is asking for cosine of 180 degrees. So 180 degrees is going to fall on my major x-axis. And I remember my major axes has ordered pairs. So in the middle, origin is 0, 0. So here's 1, 0. 0, 1 is up here at 90 degrees, which means that cosine of 180 or 180 degrees gives us this ordered pair. I'll just do this one as well. So 180 degrees is going to be here. We need to remember that our x is always cosine and the y is always sine. So if I'm looking for cosine, I want my x value. So my answer is negative 1. So part B, my answer is negative 1 as well. All right, part C, I now want sine of 3 pi over 2. So I'm going to go ahead and put that into degrees. 3 pi over 2 is 270 degrees. So 270 degrees is going to be down here, which is an ordered pair that we wrote up here, 0, negative 1. And in your ordered pair, sine is going to be the second number, or the y value. So my answer for C is again negative 1. Okay, so for part D, I'm just going to go ahead and look at what we drew in part C because part D asks us for cosine of 270 degrees. So if we look right here, we already have an ordered pair right here for 270. Cosine would be our x value. So cosine of 270 is equal to 0. So that's not going to be our answer. All right. Number 28, select the angle that satisfies both equations. So we have a negative cosine and a positive sine. Negative cosine and positive sine is going to take us to quadrant 2, right? This is where you have a negative cosine or negative x value and a positive y value or positive sine. So if I label that based on what they give me, cosine, I have negative square root 3 over 2, adjacent over hypotenuse from this reference angle right here. And then sine, which means opposite over hypotenuse, gives me opposite over hypotenuse. So I'm looking for this angle here. Where am I at in my unit circle? So to do that, I need to find this reference angle. Opposite of 1 is always going to be a 30-degree reference angle. So if this is 180 degrees, I need to subtract, because I'm going back into quadrant 2. I'm subtracting that unit or that reference angle, and that's going to take me to 150 degrees. So I'm at 150 degrees here on my unit circle. Number 29, we are going to graph a log. So log base 3 of x, and we want to figure out which has a graph that shifts this to 2 on our x-axis and then negative 1 on the y. So the first thing I'm going to do is I'm going to graph f of x is log base 3 of x. So to graph this, we're going to create a table. We have our snail method, and we're going to rewrite this as 3 to the y power is equal to x. So I'm going to create my table, x and y, and when I do that, I'm always going to pick negative 1, 0, and 1 for my y values. And when I do that, I'm going to plug that into this equation right here. So plugging in negative 1 for y gives me 3 to the negative 1 power is equal to 1/3. 3 to the negative power is 1/3. So that's going to give me my x is 1/3. Then I'm going to plug in 0 for y. I get 3 to the 0 power. It's equal to 1. So my x value is 1. And then 3 to the first power is equal to 3. So I put that 3 here for my x. So I'm going to do just a quick sketch of this, maybe over here on the side. When I sketch these ordered pairs, I have 1/3 comma negative 1. So 1/3 would be about here, negative 1. Then I have 1 comma 0 and 3 comma 1. Those would be the 3 ordered pairs right here from my table. Okay, so if I do that quick sketch, it would look something like this. But they do want us to graph this shift. So this plus 2 is telling us to take log base 3 of x and shift it left 2. Remember, the positive 2 actually means to the left. And then this minus 1 means down 1. So we're taking these points and we're shifting them left 2 and down 1. So if I take this one, left 2, down 1 would be somewhere over here. Left 2, down 1 would be about right here. And left 2, down 1 would take us here. So in red, what I just sketched would be what we're looking for, and that's going to be B. Okay, number 30. The number of carbohydrates in a 1 ounce serving of 13 breakfast cereals is listed as follows: 20, 30, 25, 25, 23, 26, and so on. We are going to calculate each of the following. So we are going to look for the range. So I'm going to remind you guys that range is your maximum value minus your minimum value. So your greatest value minus smallest. So if I look at all of these, I see that my greatest value is 30 and my smallest value is 13. So when I subtract those, 30 minus 13, I get an answer of 17. So my range is 17. So the mode we want to find next, remember, mode is what occurs most frequently. Okay, so we're looking for the number that occurs most frequently. I'm going to go ahead and skip to part C and find the median before I do the mode, just so I'm careful. So the median, we remember, is that middle number when we put all the numbers in order. So I'm going to do that. I'm going to put these in order from least to greatest, 13, and then as I go through, I'm going to just kind of cross them out to make sure I don't leave anything out. So I have 13, I have 20, I have 20 again. I'm going to do this carefully so I don't make any mistakes. 21, 22, 23, you have 23 again, 25, 25, 25, so we have 25 3 times, and then I have 26, I'm out of room, and then 28, and my last one is 30. Okay, so when I put these in order, to find the median, I'm looking for the one in the middle. So I'm going to go ahead and count off some of these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 and 1. That leaves me with 23 as my median, that number in the middle. So the reason why I wanted to do that first was because now it's kind of easier to for sure know the mode. So I rewrote 25 3 times. So 25 occurred the most frequently. 25 is going to be our mode. And the maximum just means the largest value. So our largest value, it was 30 right here. So 30 is our maximum. Okay, now we are going into our more open-ended. We have the height of adult women. Make sure I have my notes. And they're telling us it's normally distributed with a mean of 67 inches and a standard deviation of 3 inches. Okay, we're going to draw a line at the value that approximates the height at which 35% are taller and 65% are shorter. So we're looking for X. We're looking for our value in our Z-score formula. So we will be using this value minus mean divided by standard deviation, and we're going to be solving to find the value. Okay, so they're saying here we want to know the value at which 35% of women are taller and 65% are shorter. So I would say it's going to be somewhere over here where we have 35% that are taller, and then we have much more that are shorter, 65%. So this information right here is going to tell me my Z-score because I need the Z-score for my equation here. This is going to help me find my Z-score because the table gives me my Z-score given the area. Table talks about area on the left, so I need to use 0.65 as an area, which is shaded to the left, and the table is going to give that to me. So I'm going to first look up 0.65. So to find the Z-score, I'm going to look up the Z-score for an area of 0.65. So when I do that, I use my table. I'm going to go and find 0.65, which is somewhere over here. So we're looking for which value is closer. I'm going to say this one's closer. Well, either one works. I'm going to use this one. So that's going to be a Z-score of 0.38. Okay, so we looked that up. We got our Z-score of 0.38. Okay, so now I have my Z-score, that's a 0, for my equation. I also have a mean, and I have a standard deviation. So I'm going to plug those numbers into my equation. I have 0.38 for Z is equal to the value that we're going to look for, minus the mean, which is 67, divided by standard deviation, which is which is 3. Right here they tell us standard deviation is 3, and then we're going to solve this for X. So to get rid of the 3 on the bottom of my fraction, I'm going to multiply both sides by 3. So these 3's are going to cancel. I'm left with 3 times 0.38, and I get 1.14. I'm going to multiply those, and that's equal to X minus 67. Then to solve, I'm adding both sides by 67. So 1.14 plus 67 gives me a value of 68.14. So that is going to be the value we're looking for, but they want us to draw a line at the value. So here's 68, so 68.14 is going to be pretty close to 68, but a little bit above. Okay, so that would be our answer for that. Okay, number 32. The following table shows a student's score for 2 subjects. It shows the mean scores and the standard deviation. So they're giving us a value, they're giving us mean, and they're giving us standard deviation for 2 different test scores and 2 subjects. So we are going to calculate the student's percentile for math and for English. So let's go ahead and do math first. So to find the percentile, we can use our percentages from our table. So I'm going to use, again, my z-score formula. So I have my z-score is equal to the value. So for math, our value is 82 minus our mean of 77 divided by standard deviation, which is 6. And I get a z-score of 0.83. So that is not my answer. That's my z-score. And if I look this up in the table, I can find the percentile. So I'm going to look up 0.83 in my table. So my z-score of 0.83 gives me 0.7967. So my area from my table is 0.7967. But they do want percentage, so this person has that percentage of 79.67 for that score. Okay, now we're going to move on to English. So English, we're going to find that z-score so we can find the area in our table. The value for the test score is 93 minus our mean is 79 divided by standard deviation. And we get a z-score of 1.27. So we're going to look this up and find the area in the table. So 1.27 gives me an area of 0.8980. So an area from my table of 0.8980. So again, they want percentile. I'm going to go ahead and move that decimal 2 times. 89.80% or 89.8%. So that's going to be their relative percentiles for each of those scores. So in which course did they receive the relative higher standing? So they're in the higher percentile in English because 89% is higher than the 79%. So we are going to say English because the student has a higher percentile. Higher percent than what they got in math. Okay. We're almost done. Number 33, sumo wrestlers. And then we have their weight. They want to find the average weight. So another name for average is the mean. We're going to find the mean. So to do that, we're going to add all of the values and we're going to divide by the number of values. So I'm going to do that by adding 500 plus 370 plus 120 plus 450. I'm not going to write this one out for you guys because it's been a long video. I'm going to add all these values and then I'm going to divide by the number of values, so I'm dividing by 5. So when I add them, I get 1,760. I'm going to divide them by 5 and I get 352. So our mean or our average is 352 pounds. What is the population standard deviation of the weights? So that I'm going to remember my procedure, MSAR, to help me find the standard deviation. So step M, we already did. We found the mean was 352. Okay, step 2, we're going to find the difference. So we take all of our values and subtract the mean. I'm just going to go ahead and write them out. 320 minus 352. So again, just each of these values and we subtract the mean. So 500 minus 352 gives us 148. 370 minus 352 is 18. 120 minus 352 is negative 232. 450 minus 352 is 98. Zoom in, kind of writing small. And 320 minus 352 is negative 32. All right, so now I'm taking all of those values from step 2 and I'm going to square them. S stands for squaring. So 148 squared is 21,904. 18 squared is 324. Negative 232 squared is 53,824. 98 squared is 9,604. And negative 32 squared is 1,024. So that's step 3. Step 4, A stands for average. Since they asked for population, I just find my regular average. So I'm going to be adding all of these numbers and then dividing them by 5. So I'm going to add these. I'm not going to write it out just because of time. I'm adding 21,904 plus 324 plus 53,824. Ooh, let me double check that. Plus 53 plus 9,604 plus 1,024. That's going to give me 86,680, but I need to divide that by 5 because there's 5 values. And when I do that, I get an answer of 17,336. So I'm going to take that number and I'm going to do my last step. I'm going to do the R, which stands for square root. So the square root of 17,336 gives me 131.6. We'll do 2 decimal places. That would be our answer. That's our population standard deviation. Okay, so to be eligible for the competition, a wrestler's weight must be within 1 standard deviation of the mean. Which wrestlers are eligible? So we are talking about these wrestlers right here. Here's their weight, and we want to know which ones would be eligible. So if we draw a picture, we know in the middle is going to be our mean, and our mean was 352. We found our standard deviation to be 131.66. So if I was going to lay out these, 1 standard deviation above would be if I took 352 and I add my standard deviation, which is 131.66. So 1 standard deviation above would be 483.66 pounds. Okay, but they say within, so we need to know this means above and below the mean. So I'm going to go ahead and find 1 standard deviation below by taking 352 and this time subtracting my standard deviation. So 352 minus the 131.66 gives me 220.34 pounds. So the wrestlers have to be within, which means they need to fall somewhere between 220.34 pounds and 483.66. So 500 pounds for wrestler A is like over here, right? So wrestler A does not get to be eligible. 370 pounds is going to be between these. So somewhere over here is going to be wrestler B. So wrestler B will be eligible. 120 pounds is going to be over here somewhere for wrestler C. So wrestler C is not eligible. 450 pounds falls somewhere over here. 450 pounds for wrestler D, so he falls within 1 standard deviation. He is going to be eligible. And then 320 pounds is somewhere over here. So wrestler E is also going to be eligible. So we have wrestlers B, D, and E that are going to be eligible because they fall within 1 standard deviation. All right, good job, you guys. Make sure that you are studying well for this test.